On with section 10 is it's about credit cards. And I think credit cards as financial is probably the easier one, but this is a type of question that's always missed. So I really want to stress it for you so you don't miss it, okay? Because I want everyone to do really well. So, section 10 is credit cards, 11 is going to be loans, and then 12 is retirement, okay? And that's what your project's going to be about, but we'll get to that at the end. So, Section 10 is credit cards. Section 10 is the start of the financial life sections. Credit cards are a common form of investment for a large and small purchase. Credit card is like an open account in which you can borrow money, but you must pay back a portion of the money later. Initially, to make a purchase and have a full month to pay off the balance. If not, then you get interest charged based on the amount you borrowed. This is called financial charge. Knowing that we were going to go over this, uh, I was like, hey, what's my credit card statement? So I looked it up and made sure that I paid last month's bill. Just thinking about credit cards, I was like, I probably should check my credit card. I don't know if I've checked it. I'm pretty sure I paid my bill last month, but as did. It just made me scared. So, credit card. So I don't know if you have a credit card or if you don't have a credit card. My in-person class, we started this yesterday, and it was about 50-50 of students that have had credit cards or do have a credit card and don't have a credit card. And of course, I'm not talking about a debit card because that acts differently. I'm talking about a credit card. So a credit card, you can buy, you have some kind of limit. You can spend up to that limit, but they charge you an interest rate. So they charge you money for buying things on the credit card. Debit card doesn't work that way, of course. Debit card just takes money out of the account, almost instantaneously. So that's the difference. But with the credit card, you may already have one, so you'd know that there's some kind of interest rate, there's some kind of fee, and everything with a credit card happens monthly. Okay, so there's going to be a lot of dividing by 12 because everything happens by the month. All right, so with the credit card, there's no question, it's every month. All right, 12 months out of the year, and it doesn't matter if it's a holiday, it's all the time. All right. So these credit cards always give you this APR value. And the APR is the yearly rate. Okay. So this is by the year. Annual percentage rate. Okay. So this is pretty common, 22.99. Credit card interest rates are very high. Uh for your first credit card, um, and depending on your credit score, 22.99 is pretty common. In fact, I mean, this is me personally, I held off to get a credit card until basically until I had a kid. I was always so scared of them. I didn't want one. And so I got my first credit card just a few years ago. And so because of that, my interest rate was really high. But after you start paying it off in reality, not in math class, but as you pay it off, your interest rate will go down. They'll decrease it as you boost your credit score and that kind of thing. But in our math problems, it just stays, all right? So there's a difference between reality and math class, um, right there. Um, and that would just to simplify the math, okay? So um, we'll always have the same APR within one problem. So find the finance charge, a carryover balance of $500 with the APR of 22.99. So that's the yearly rate. That's the percentage rate that they're offering. That's what they're doing. And let's say we bought, we went to the store and we had to maybe buy a new laptop for school or something for 500 bucks. So they're going to charge us an interest. They're going to charge us interest on that $500. Okay. So we go to Best Buy, we need a new laptop like right now. Our last one broke. We have to go get one. We get $500. That's what we think we can spend. And this is what the credit card's going to charge us. They take that 22.99, divide it by 12, and times it by that $500 purchase. And so they're going to charge us $9.58 for spending that $5. So now your credit card bill is going to be 509.58. So now that's what you owe on the credit card. So they charged you to do that. Okay. Find the finance charge on 1300 with an APR of 29.99. So this is really high. This is really high. But we can find that finance charge. Okay. So also in reality, um, different places will have different deals. We're not going to talk about deals in this class because it only complicates the math. But of course, like if you went to Best Buy, you could sign up for their credit card and they'll offer, interest free for this long. Maybe you have 3 months or 6 months or until Christmas or something like that. Interest free, you can make payments and there's no interest. So that is also something that happens. Or if you're buying in-store purchase, there'll be some kind of discount. Those are all things in reality which only complicates the math, but is a better deal for you. We're not going to do that because it only complicates the math. So we're just going to go straight forward finance charge. Okay. So, um, not to confuse the matter, but just try to explain the difference between things that are going on in reality versus math class. And math class, we're just trying to look at the simplest case to understand that. So the finance charge on this purchase is going to be the APR. We need to turn that into a decimal. And then we need to divide by 12 because everything happens monthly with credit cards. It's a monthly thing. And then we're going to times that by the purchase. So I'm not sure what this person bought, but they spent $1,300 on this credit card. And this one in particular has a very high interest rate. So I would take my 229.99 divided by 12 times 1,300. And I'm getting that the finance charge is going to be 32.49. Okay. That's the finance charge. You'll have a lot of questions on your homework that says, find the finance charge with this scenario. So this would be a common homework question. And you'll see it when you get to the exam, you'll see that too. So that's something that we got to watch out for. Okay. I will warn you, the next few questions are long and tedious. Okay. I'm going to go it step by step, though. I'm going to try to explain everything I do, but I'm just going to warn you. If you thought this class was boring before, wait till you get to this one. Okay. So just bear with me. It's long, tedious, and I put a whole classroom full of people to sleep yesterday by doing it, but I want to show each step I do. And, what am I going to do? I'm talking about finance charge. How exciting can it be? But I want to at least show you every step I do. So here we're spending 2,000. We have the rate 15.99 APR, and the minimum payment is 7%. Credit cards have a minimum. You have to pay something each month. If you don't, there's a penalty. So this credit card is 7%. That's pretty common, maybe a little high. Usually it's around maybe a little less than 5% you have to pay, or like $25. So they'll have, in reality, your credit card will have two options. It's 5% or $25, which one's ever more. So that's something that credit cards will do. You'll have to do this or that, whichever one's more, which is more complicated than what we're going to do in class, but that's reality. So here's the purchase. The first thing I have to do is find that finance charge. And the finance charge is going to be the, in this case, 15.99 divided by 12 because everything happens monthly times, and I'm just going to put capital B for balance. Okay, so that's this step right there. All right, now 0.1599 divided by 12 times $2,000, and there's my finance charge. So they're charging $26.65. Okay, now what's the new balance? What does that mean, new balance? What on earth's going on here? What we're going to do is we're going to add the carryover balance plus the finance charge. So plus the 2,000 we actually spent. Okay. So that's $2,026.65. Okay. Now they're going to make us pay minimum payment. And for this example, we're just going to pay the minimum payment. Of course, you could spend more, but we're just going to find the minimum payment, or we're just going to pay the minimum payment. The minimum payment for this credit card is 7%. So we have to pay 7% on the new balance. All right, how do you find 7% of a number? So I'm going to multiply it by 0.07, 7 per 100. And there is my minimum payment, $141.87. Okay, first line is done. First row is done. Now, we have to pay the minimum payment. We have to pay this. Okay, so this is our balance, our credit card statement. We have to pay the minimum payment for this example. We're only going to pay the minimum payment. So I'm going to pay it. So I'm going to take the difference between these two numbers and find what would be the carryover balance. 20, 26, 65, 1884, 78. 1884, 78. Let's check that. Short-term memory skills, 1884, 78. Okay, looks okay. All right. How did I get that number? New balance minus minimum payment is carryover balance. Okay. Now I got to start this process all over again. Now I got to find the finance charge. Okay. So the finance charge on what? On this number. So they're going to charge me every month. So 0.1599 divided by 12 times 1884.78. And there it is. This month's finance charge is 2511. Okay. We see it's going down. The finance charge is going down every month because we are making payments, but it's not going down to zero. So now the new balance is adding these together. So carryover balance plus the finance charge 2511. And there is our new balance, 1909.89. 1909.89. That's my new balance. And now I have to find my minimum payment. For this credit card, the minimum payment is 7%. So I need to find 7% of the new balance. 1909.89 times 0.07. Not times 7, but times 0.07. 133.69. We see it's going down, but we can imagine it's going to take a while to do this if we only paid the minimum payment. We have to make this payment, so I'm going to make this payment. Okay, so I'm going to take the difference, this minus this, 1909.89, and there is our month 3 credit card bill, 1776.20. If I round, I'm going to have to do 20 cents. So 1776.20. There we go. Okay. That's how you do it, right? So I'm going to do yet another example to really make sure that this is clear, but that's the scenario. So they give you the APR, but you have to remember you have to divide that by 12, and to find the finance charge, it's the APR divided by 12 times the balance. There's the finance charge. New balance, you add these together. Minimum payment is whatever they told you the percentage was. Then you pay that. So you're paying the minimum payment on the new balance. So you subtract these two numbers, and there's your balance. And you have to do it all over again. Finance charge, and add those together. You get the new balance. Then you find the minimum payment. Then you pay the minimum payment. You find that carryover balance, and so on and so on and so on. Okay. Let's try this one. It's the same process, different numbers, but we'll see what's going on. So again, I have some carryover balance. I have a different APR. I have the same minimum payment for whatever reason. And let's see what we can find. So remember that finance charge is 0.1999 divided by 12 times the balance. Okay, so let's try to find the finance charge. So doing that, I got my balance on this card. Oh, you know what? I'm going to go point APR divided by 12 times 950.5. And the finance charge is $15.83. Okay, now how do you find the new balance? We're going to have to add that to the carryover balance. Okay, and so that's 966.33. 966.33. Okay, and the minimum payment on this credit card is 7%. So we need to take 7% of this number times 0.07. What do we get? 67.64. All right, now I need the carryover balance. How do you find the carryover balance? You take the difference of these two numbers because we're going to pay this. So we're going to pay that. 966.33 minus 67.64. 898.69. 898.69. Okay. Now the finance charge. So you take your APR, divide it by 12, times it by the balance. 898.69. Finance charge is 14.97. Okay. Now we have to find the new balance, and the way we do that is we're going to add those two numbers together. So 898.69 plus 14.97, 913.66. Now I have to find the minimum payment. For this credit card, that's 7%. So I'm going to times that by 0.07. And there we have 63.96. Okay, we see it's going down. Okay, but they're still pretty close together, right? Because we're only paying 7% on that. Now we want to find the carryover balance, so we got to take the difference of these two numbers. Okay. So we take our balance, we're going to subtract that minimum payment, 849.70. That's our new carryover balance, 849.70. Okay, there it is. Now we got to find the finance charge. How do you do that? Take your APR, divide it by 12, times it by your carryover balance, 849.70. And that's 14.15. Okay. So the finance charge, we see it's going down, but just little by little. All right, we want to find the new balance. How do we do that? We need to add these two together. Okay. 863.85. 863.85. Okay. And then we want to find the minimum payment for this credit card. Minimum payment is 7%. So we need to multiply this by 0.07, and we get 60.47. All right. So there's the minimum payment, and we're going to pay that. So we're going to go new balance minus minimum payment, and that'll be the beginning of month 4. 863.85 minus 60.47, 803.38. What did I say? 38. All right. So it said find the starting balance for month 4 if the account with carryover balance is $950.50 with the APR of $19.99, and minimum payment must be 7% of the total balance. So that's me filling out the chart, right? Pretty labor intensive. There's no formula. I can just plug it in and find month 4, but that's how you do it. Each step is fairly easy, but there's a lot of steps involved. Okay. One more example. 2 makes it true, but 3, hopefully third time's a charm, right? So APR is $25.99, and so the finance charge for this is $25.99. Turn it into a decimal, divided by 12 times the balance. Minimum payment 4.5%. Each month there's additional charges. So this time they're buying stuff. So last time we just always made one big purchase and kept paying it off. First one big purchase and just kept paying things off. This time, not the case. This time we have new purchases. So it complicates things. But luckily we have a chart here to kind of show us exactly what's going on. So we have a starting balance of $100. That was some kind of purchase we made. 0 for the first month. New purchase is $950. So then we have a new balance, minimum payment. We're going to pay it. Then we have finance charge, then a new purchase, then a new balance, and a minimum payment, and so on and so on and so on. So in this case, we have new purchases. We're continuing to pay and buy new things. So that complicates things. So the new balance would be $191.50. Okay. Now we have a minimum payment on that. And for this credit card, it was 4.5%. All right. So 191.50 times 0.045, and that's $8.62. All right, now we're going to pay that. 191.50 minus $8.62 is 182.88. Okay, now we're going to have a finance charge. So they're going to charge us on this. So we have 0.2599. That's the APR, but we turn it into a decimal. We divide by 12 because credit cards, everything has to do by monthly. Then we're going to multiply that by the starting balance, 182.88. All right. And that's $3.96. Okay. So we also make a $60 purchase of something else. And so what is our new balance? Well, it's our starting balance plus $3.96 plus $60. And there is our new balance, $246.84. All right, and we're going to make that minimum payment on this credit card. That is 4%, 4.5%. So times 0.045, is 1111. All right, we're going to make that payment. So 246.84 minus 1111, and that gives me $2.35, 235.73. 235.73. Now let's find that finance charge. 0.2599 divided by 12 times starting balance 235.73. And we find the finance charge this time is $5.11. Okay. Plus a new purchase. So that's going to be our new balance. We have to add these up. 73 plus 511 plus 5520. 296.04. 296.04. Minimum payment is 4.5 times 0.045 is 1332. All right, and the minimum payment is paid, so we're going to subtract these. 296.04 minus 1332, and that's 282.72. 282.72. So I think that is the starting balance a month for with all of these new purchases. Okay, that complicates the math quite a bit, but we can still do it. Just have to know when to add, when to subtract, when to multiply, and when to divide. Okay. I think each step is easy, but tackling the whole problem at once is nearly impossible for me. So that's a lot. It's 3 versions of the same problem. Third one's quite a bit more complicated, but are there any questions, comments, or concerns about what I just did with credit cards? Is there anything you would like to see done again? Is there anything that didn't make sense? Is there any questions whatsoever about those credit cards? Does it make sense where the numbers come from? Does it make sense why I was multiplying by 7%? Is it clear how I got the carryover balance? Any questions on those? So I guess I'll just uh, say one last thing. APR, make sure you turn it into a decimal. That has to be done. Make sure you divide by 12. Everything with the credit cards divided by 12. So APR divided by 12 times that balance. So that's how we're getting that. Okay. Hopefully it's making sense. If it's not, I want to hear from you. Um, in these examples, we only pay the minimum payment. Of course, you could pay more, but that's not what we're doing for the math problem. We're just paying the minimum for our math problem. But in reality, you could. And it reduces your interest by quite a lot if you just pay more than the minimum. Okay. All right. Hopefully it goes well. Section 11. Section 11 is the beginning of the hard stuff. So 11, there's a few things that we cannot calculate with just a normal calculator. And I'll show you what those are, and I'll show you exactly how to get those numbers. But Section 11 is the introduction of loans. Okay, this is the beginning of loans. And what's the deal with loans? So a classic loan. For the most part, we're going to think about buying a house, or buying a car. That's the two different scenarios I think are most common and that we'll focus on. The two numbers that we cannot calculate with just a scientific calculator, or most scientific calculators, I should say, is the payments and the size of the loan. And so the way I'm going to show that is I'm going to use a spreadsheet program to calculate those numbers. So there's two numbers I have to use, um, either a graphing calculator or a spreadsheet program to do it. So I'll show Excel and how you do it. But of course, you can use Google Sheets if you want. But here's the idea. So we have um, the size of the loan is going to be the PV, and the payment is going to be PMT. Um, so PV is the loan, and PMT is payments. Now, just before we get into all of the details, if you're buying a car, there's one idea is that you say, well, I could afford a car payment of $200 a month. With If they give me an interest rate, what's the most expensive car I could buy with it being $200 and whatever the APR they give you? So you could calculate what's the most expensive car you could buy. Okay. So that's the idea of finding the size of the loan. So if you start with the payments, you could find the size of the loan given they're giving you some kind of APR. The other idea is that you have a car in mind and now you want to find the payments. So let's say you have a car in mind, it's $15,000. They give you an APR. You can calculate what the size of the payments are. Okay. Of course, in reality, there's all more complications like insurance, down payments, which we will get into down payments, but there's even more complicated things that can lower that number, but this is just the basic calculation. So you have PV, present value of the loan, versus PMT, payments. Those are the two ideas. Okay, so PV, you're starting with the idea, you're starting with the payments, how much you're going to pay each month. PMT, you're starting with the size of loan, you're finding the payments. Okay, I'll show that, I'll explain that all again later, but that's the idea. Your calculator cannot find the value of this loan. It's not quite true. There are some scientific calculators that have finance buttons inside them, but almost every calculator is different. So we're just going to say just going to use the spreadsheet program to do it. Graphing calculators, if you have a TI-84 or TI-83 or more, they have it somewhere. Depending on which calculator you have, you can use those to find the payments, but in class, we're just going to use Excel to do it. Okay. Here's how we do it. This is our cheat sheet. You take the monthly rate, the payments, and negative monthly payment for the loan, and then PMT is the monthly rate, number of payments, negative total amount borrowed. So I'll show this in real time of how this works, but here's your cheat sheet. Of course, I'll post the notes after class, but um, that's the idea. Okay, so we're going to use Excel to calculate these things. We can't calculate it by hand. So you have found a home for $100,000 that requires a down payment of 15%. How much should you borrow? This is just talking about down payment. So often when you buy a house, and this would not be a very expensive house, um, you would only borrow outside of the down payment. So there's something you have to put down first, and then you're going to borrow the rest, right? So there's a couple ways you could calculate this. You have $100,000 and that requires a down payment. So often my students will want to go, okay, times 0.15, there's the down payment. So the down payment is $15,000, okay? Whoops, I didn't mean to hit the microphone. So I'll just write down it's 15,000. So we don't need to borrow, we don't we don't have to borrow the full 100 because right here we're putting 15 down right now. So what are we going to borrow? We're going to borrow 85. Okay. It's not the only way to calculate that. It's just generally my students' favorite way to calculate it. The other way to calculate it is if we're doing 15 down, what do we need to borrow? We need to borrow 100% minus 15%. So 100,000. Whoops, I hit the wrong button. 100,000 times 1 minus 15% is 85%. So 85% is what we're going to borrow. So 85,000. It being 100,000 makes the arithmetic uh, much easier. But anyway, that's down payment. So we're not going to borrow the down payment. We have to put that down right now. If the interest rate is 2.5% for 20 years, what would you type into Excel to find the monthly payment? Try it out. Okay, let's try it out. So the interest rate is 2.5%. It's 20 years. What would we to calculate the monthly payment? So we're going to find how much these people are going to pay each month on this house. Okay, so what would I type in Excel? I type in equal sign PMT, open parentheses, and then 2.5% divided by 12, because we're going to pay monthly, 12 times 20. And then how much are we borrowing? $85,000. And I'm not going to put a comma there because it'll get confused. So there we are. That should do it. That should give me the payments. So that's using this formula right here. Negative is because that's what we're paying on. Okay. Now let's actually do it. All right. So if I did this right, you should be able to see Excel in the bottom right corner of my screen. And I'm going to hit the equal sign here to wake up Excel and say, I'm going to need you to calculate something. PMT, so I typed in PMT, open parentheses, 2.5% divided by 12, comma, 12 by 20. That's how many payments we're making, minus $85,000. And I'll close parentheses and hit equals. And that's not right. I think I got an extra zero there. There we go. They're going to pay $450.42. Now, of course, that doesn't include uh, homeowners insurance or anything, that's complicated like that in real life. Minus 85. There we go. Okay. So they're going to pay $450.42. All right. 42 cents. So you'll notice I had to use Excel to get that value. All right. If you have a graphing calculator, you can do it on a graphing calculator as well. There's a finance section somewhere on there. But for the most part, we're just going to use a spreadsheet program. Google Sheets should work the exact same. They all work the same. If you're on the Mac, you can use Numbers. That's Mac's version of it, and it'll work the exact same. Okay. If you're on Linux, you can use OpenOffice or whatever they got, and it'll work the same. Any spreadsheet program has this. They all have it. Okay, how much will be paid over the lifetime of the loan? How much interest is paid over 20 years? So how much is paid over the lifetime of the loan? Well, they're paying 400, let's see, 450.42 every month for 20 years. Okay. Now this I can just use a normal calculator to do. I don't have to have the fancy functions for this times 12 times 20. Okay. And there it is. So that's how much they're going to pay over the lifetime of the loan. So we see it looks like they're paying $8,100.80 in interest. Okay. So how much was in interest? So this is total in interest. Just write interest is the total minus um, let's say borrowed. That would be better. 108 180 minus the 85 we borrowed. Okay. So that is how much interest we paid. $23,100.80. Okay. Make sure I wrote that right. 23,180. Yeah, that looks right. Okay, I'm gonna circle it because I kind of crammed it down here. Now again, how did I get this number? I used Excel. So that came from Excel. I did not calculate that by hand, right? You can use any spreadsheet program, but you have to put the equal sign to be able to do it, right? That's the idea. Now, I have lots more examples here, so let's keep going, but hopefully it'll make sense by the end. What is the highest price house you can get with the following? Monthly payment, $550, APR 4%, 30 years. Highest price. So highest price is the size of the loan. Okay. So before we had to use Excel to find the payments. Now we're going to find the size of the loan. And that's the present value function. Okay. So I'm going to write down what I'm going to type in Excel. Present value. And that's at 4% APR. We're going to pay monthly. So divided by 12. 12 times 30 years. And then each month we're paying $550. So this will tell me the size of the loan. All right. This is what I'm gonna type in Excel, and it's gonna find me what size loan we're gonna have. Okay. Go. Take that away. Equal sign PV 4% divided by 12. 12 times 30 years minus 550. All right, so there it is. 115,203.68. Okay. That's the size of the loan that they can borrow, right? Now, if they have a down payment, they can go higher than that, of course, but that's the size of the loan, okay? What did I say? 203, 68. All right. Now I got this from Excel. So let me make a note of that. This came from Excel. I did not calculate that by hand. All right. Any questions about how I'm doing that? Is it clear what I'm doing, how I'm doing it? Are there any questions? I would assume this is new for everybody, unless you took some kind of accounting class or something. So I would imagine you're seeing this for the first time. So you found a car, $19,580, APR of 3.33. 6 years, that's common. Monthly payment was what we're looking for. How much interest is paid over the loan? Assume a down payment, 5 grand. Okay. So what are we going to do first? I would say the first thing we're going to do is we're going to do that down payment. So 19,580, and we're going to pay 5 grand on it. That's first step. Okay, this is the down payment. 19,580 minus $5,000, 14,580. Okay, that's what we're going to borrow. All right, we have the APR, we have the amount of time, and so now we need to find the monthly payments. So how do you find the payments? That is the PMT function, and that's 3.33% divided by 12, 12 by 6 years. And how much are we going to borrow? 14,580. All right. So this will give me the monthly payments. And that's one of the questions that we have to answer. So let's do that. So PMT, 3.33% divided by 12, 12 by 6 minus 14,580. And we get $223.68. 223.68. That's per month. And that's an Excel value. That's how I got that. Put my reference down. So that's Excel. That's where that came from. And there we go. So that's what they're going to pay every month. Now it says how much interest will be paid over the lifetime of the loan. So how do you find interest? Interest is going to be total paid, or the monthly payments minus the borrowed. Okay. So let's find that. Now, what are they paying on the payments? Let's do a normal calculator. 223.68 times 12 times 6 years. So there it is. Paying $16,104.96. 16,104.96. How much did we borrow? 14,580. And that difference is the interest. Minus 14,580. So $1,524.96. 1524.96. That's the interest. All right. So there's quite a few questions there. You found a car for $19,580 with the APR of 3.33% for 6 years. What's the monthly payment? How much interest was paid over the lifetime of the loan, assuming down payment of $5,000? So what's the monthly payment? I think it's $223.68, but I had to use Excel to find it. This is the formula I typed in. So that's how I found it. Okay. Because of the down payment, I didn't borrow the full amount. I only borrowed the difference. Okay. So the difference of the price of the car minus the down payment is what I actually calculated for the payments. $223.68. Now they want to know the total interest. So how much are we actually paying? It's this every month for 6 years. So I took this number times 12 times 6. Here we go. That's how much they paid in their payments. And then subtract how much we borrowed right there. And this would be how much they paid in interest. Okay, that's the idea. All right. Hope it makes sense, but it's quite a bit more involved than things we've done in the past. And we have to use Excel for one of the numbers there. So find the total price of a house if the monthly payments are $610 for 25 years with the APR of 199. All right. So we're finding the loan. So total price, we want to find what is the loan. We know the monthly payments, we know for how long, and we know the interest rate. So we can find the size of the loan. Now for this, because we want to know the loan, it's PV, present value of the loan. 1.99% divided by 12, 12 times 25 years, and then each month we're paying $610. So I'm going to type this into Excel, and that'll tell me the size of the loan. Okay. Equals PV 1.99% divided by 12, 12 times 25 years minus $610. And there it is. Okay, so no down payment this time. So $144,082.80. 14482.80. I think I wrote that down right. 14482.80. Yep. Right. I used Excel to calculate that. So I didn't calculate that by hand. I had to use Excel to do that. But I typed in this formula in Excel to do that. Right? So find the total price of a house with the monthly payments 610 for 25 years, APR 199. There it is. Okay. There it is. All right, let's keep going. What is the total paid for a loan? 3,200 for 3 years. APR is 6.8. Okay. So no down payments, nothing to do that. We want total paid. What does that mean? Well, total paid isn't the size of the loan and it isn't the payments. It's the total amount this person paid on it. So what is that? Well, that's the payments times the number of payments. Okay. So we've done this before, but we've never been asked it in this direct way. So the first thing I need to do is I need to find the payments, and then I need to find what's the total paid, and then I can do it. All right. So equals PMT. We're at 6.8 divided by 12. 12 times 3 years, and we borrowed $3,200. Okay, this will give me the payments. And then I can find total paid once I get this number. So I need Excel to help me with this. Okay. Equals PMT 6.8% divided by 12, 12 by 3 minus 3,200, $98.51. Okay, I use Excel to find that number. So in case you're looking back, where does this number come from? I used Excel to do that. Okay. Now I'm going to multiply that because this is per month, right? Per month times every month times 3 years. Okay. All right, there it is. So that's what we actually paid. 35, 46, 36. 35, 46, 36. 35, 46, 36. Got it. Okay. Total paid. So what's the total paid for a loan of 3,200, 3 years, APR, the loan 6.68? There it is. $3,546.36. There it is. Okay. Total paid. Number 10, consider a house, 185,000, no down payment. The APR is 3.58 and it's 35 years. Total paid on the house, total interest on the house. Okay. So how do you get total paid? That's what we did last time. Last time we had to find the payments and multiply it by how many payments. All right, so let's do that. To find the payment itself, I'm going to have to write equals 3.58% divided by 12. 12 times 35 years and minus $185,000. This will give me the payments. Okay. Equals PMT 3.58% divided by 12. 12 by 35 minus 185,000. And there's our payments, $773.19. 773.19. All right. Just to be consistent, I got this from Excel. In case you're looking back. Now, what's the total paid? This is per month, right? Times 12 times 35 years. All right, this will be the total paid. All right, there it is. That's the total paid. $324,739.80. 324,739.8. I say 739. 324,739.80. This is total paid. There it is. All right. Find the total interest of the house. How do you find the total interest? Well, this is the total paid, and that's what they initially borrowed. So the total interest is going to be the total paid minus what they borrowed. Okay, so let's see what that would be. Minus 185,000. Okay, and there it is. That is our interest. 139,739.80. 139,739.80. This is the total interest. There it is. So if you want to find the interest, you have to take the total amount that was paid minus what was borrowed. And whatever's left must be the interest, right? That's what the bank gets out of it. All right, that's the idea anyway. So consider a house with 185,000 with no down payment. APR is 3.58% for 35 years. Find the total amount paid for the house. Find the total interest. So we had to find the payment first. I had to use Excel to get that number. Then to find the total paid, I took the monthly payments every month for every year, 35 years, and there's the total paid. Total interest was the total minus the borrowed, and there we go. Total minus borrowed, and here we have the total interest. Okay, that's the idea anyway. All right. Any questions about that? Questions, comments, or concerns? All right, let's look at the homework. Section 10 and 11. Take quiz. Find the finance charge for the following. Balance, APR. You're just finding the finance charge. What's the finance charge of the credit card if the balance is 660.30 cents? APR 6. So I did many of those this morning, right? So it should be, I mean, if it made sense, you make sure you take the APR, turn into a decimal, divide by 12, multiply by that balance. That's the finance charge. All right, this one you have to work a bit more. You can see that. It's very similar to that last credit card I had. Monthly carryover, new balance, so that's going to be 100. The minimum payment is 2.5%, so $2.50. And then monthly carryover, finance charge, so very similar to that last example I did with the credit cards. This is probably more in line with maybe the second example I did, where you have a carryover balance, a finance charge, a new balance, a minimum payment, and so on and so on and so on. So I did one very similar to this on, I think it was the second example. And this is very similar to the previous one. We have a balance, APR, minimum payment 7%. One of my examples was 7%, so you saw how I did that. What is the balance on the credit card? A month 5, you only pay the minimum payment. Initial carryover is this, APR is this, minimum payment. So here you're not filling out each step. You have to fill that out on your own. And you're going to give me or give the computer month 5. So you're going down here and you're going to go one more month and then 5. So you're only writing what you get after month 5. So there isn't the multiple steps. You have to work it all the way down yourself. Okay. So you're kind of on your own on that one. You have to actually work it out, and that's why it's worth more points. This one's worth 4.5. This one's only worth half. So you got to work a little bit more on that one, and you got to go each step. But hopefully by question 7 on your own and cross-referencing what we did in class with the notes and I guess this video, you should be able to get it. Okay. All right. So that is section 10 homework. Yes, I would like to continue to exit. And then section 11, let's take a look at that. 11 questions for this one. This is a hard one. 11 is one of the, I think, the biggest sections of the class. Here you have multiple choice. Looks like they're all payments. And let's see, we have an APR of 1.09% divided by 12, right? Of course, so 0.0109 divided by 12, that looks good. And then how many payments? 16 years times 12. So this one's kind of my guess so far, $900. So that one you're just guessing of what you would put into Excel, or not guessing, you're picking a multiple choice. Doesn't have to be a guess. Here you're going to find the loan, so it's $90 monthly payment, 1.05 APR, 6 years. So should be able to calculate that. And then here you have to actually start calculating yourself. So we have a car, $29,000, 7% down. You can borrow the rest, 2.99 APR, 48-month loan. So that's telling you how many payments there are. You don't have to um, do the 12 times the year because it's just saying it's 48. How much would the payments be? So here you're looking for PMT. What kind of loan can you get with $700 each month? Um, Yearly rate, very, very low for 10 years. So you're looking for the loan, that's present value. That's the PV function. What monthly amount is needed for the car loan starting at 8,000, 3 years? APR is 0.65%. So um, you can, you're going to have to use a spreadsheet for that. Okay. How much money can you afford for a loan if you're going to pay $80 each month? So this is giving you the payments, the years, and the interest rate. All right. Donald Trump admitted to receiving a small loan of $1 million for his father. If he paid back the loan over 32 years of a fixed rate of 3%, how much would he have to pay each month? Okay. So in this, $1 million borrowed, 32 years, 3% interest rate. How much is the monthly payments? Consider having a personal loan that spans over 50 years. The loan was taken out for $1,000. The interest rate is 5.99. How much interest would have been paid after it's paid off? So this is not asking for the loan. It's not asking for the payments. It's asking for the interest. All right. Reference those last few examples I did in class. That will help you. What is the total interest? Okay. So watch out for what this is asking for. This is asking for interest. We did those in class. So be careful. If the home is 136,000, what is the down payment? It's 20% down. So you're going to write what 20% of 136,000 is. How much is he going to borrow? Well, it'll be 80% of that number. Use Excel's PMT function to determine how much the payments would be. So you're going to have to actually use the PMT function to be able to calculate this number. How much will he pay interest over the lifetime of the loan? So this is asking for the interest, not the payments, not the total paid, just the interest. So look out for that. Watch what it's asking for. House price, APR, down payment, the loan times 30. So how much must you borrow? Well, if you're going to do the down payment, you want to take that away. What are the monthly payments? And what is the total price of this house, including interest and the down payment? So you're going to see what is the total amount paid over the whole thing. Total paid, right? That's question 11. So we did one like that in class as well. So hopefully you can kind of cross-reference that. All right. Those two homeworks, and they're hard ones. So allow yourself a little extra time for that. Okay. Definitely read it out loud of what it's actually asking for. Okay. If it's asking for, well, just be sure, if it says interest, you know what you're answering. Okay. So watch out for those things. All right. Always tricky. All right. There shouldn't be any errors or anything like that with the homework this time. So, um, keep trying, keep trying. All right. Are there any questions, comments, or concerns about 10 or 11? I'm going to upload those notes after class. Okay, if there's no questions right now, what I'm going to do is I'm going to take a break. I'm going to go make another pot of coffee. We're going to come back and we're going to talk about future value. We're going to talk about retirement programs. And then after that, if there's time, we're going to talk about project 2. Okay, so we'll get started with project 2. All right. So let's meet back at 10:30. just an even 10:30. That should be enough time for me. So I'm going to take a break, come back at 10:30. Right now it's 10:19, so we'll come back and talk about retirement programs. Okay, I'm back. If you are back, um, could you say hi in the chat? Okay. The next thing we need to do is we need to talk about section 12, which is kind of a continuation of 11. And instead of borrowing money, we're going to save money with an interest rate. And this time it's generally it's a retirement is what this would be uh, what would be used for. So yeah, instead of borrowing money, we're going to save money with the retirement program, but there's going to be some kind of interest rate. And there isn't really a down payment for retirement program, though I guess there could be in reality. But there isn't a down payment, but sometimes a place that you work at will have some kind of contribution to the account. So they might match to some percentage of what you're putting into the account. So that can be different. Okay. Um, so and that complicates the math a little bit. But anyway, that's the difference between it. So before we were borrowing it, now we're gonna save it. All right. So hopefully that'll make sense. All right. And then if there's time today, which I think there might be, but if there's time, we're gonna go over project 2 a little bit. All right. Okay. So let me get out of that. And let's go to section 12. Okay, section 12 is the last section before the test. So this is the last information before the test. All right. So the test is 7 through 12. So this is the last new stuff. This week has section 12, which is related to section 11. In Excel, it's used to calculate some of the answers. Consider the example below about saving for retirement from a job. Johnny has a job that earns 4,000 gross pay each month. Taxes are 20%, and he contributes $200 towards his retirement. If his job matches 30% of his contribution, answer the following questions. Okay, so it looks like we have a three-parter. How much is his take-home pay after the contribution and taxes? So what's going on with this contribution and taxes? So a big thing I need to mention is that you are not taxed on your contribution to your retirement. So if whatever you put into your retirement account, it is not taxed. It's taken out of your check before you pay your taxes. Okay. Of course, this is how the rich stay rich, but the contribution is not taxed. So we need to take it out of the pay before we tax them. All right. So anyway, let's write down what's going on. So we got 4,000 for the month, and we're going to take out 200 before we tax them. Okay? That's how it works. So what's that going to be? 380. Now we're going to get taxed. So we take out the contribution first, then we tax them, and 20% tax. So we're going to take home 80% of this. Or if you want, you could take 20% of this and subtract it from this original. But I'm just going to multiply it times 80. Okay. So 3,800 times 0.8. And that's going to be the take home. Okay. So times 0.8 equals, yeah, this is my take home. All right, that's it. That's how it works. So that's after contribution and taxes, but please note that we take out the contribution first and then we tax. How much will Johnny contribute for 30 years? How much will his employer contribute for the 30 years? All right, well, Johnny's putting $200 each month, each year, and there's 30 years. Okay, so that's 200 times 12 times 30 years, and that's $72,000. Okay, how much will Johnny's employer contribute? So the job matches 30%. 30% of the contribution. Okay, so what's going on with that? 30% of 200 equals $60. Okay, so the job is doing $60 each month times 12 times 30 years, right? So times each month for every year, we get 21,600. Okay, so that's what they contribute. So this is what Johnny put in. This is what the company put in. What ratio represents the company's contribution to the total amount invested? All right. Well, it's just kind of a silly math problem. There's nothing super important that we need out of this, but I'll answer it anyway. But this was probably more interesting, and I really hope part A made sense. I hope I explained it well enough with that you take out the taxes after the contribution. Very important to note, so I hope I explained that well enough. What ratio represents the company's contribution to the total invested? So what's the company? They did 21. And what is the total contributed? Well, we had 72. And then, of course, there. Okay. Plus 72. So 93,600. Okay. So that's one version of the ratio. I'm wondering if I can reduce that down a little bit. Um, yeah. So now I'm just thinking about the arithmetic. Can I reduce this at all? 216,936. Yeah, I can reduce that. So 6 and 3 is 9. So this is a factor of 3. That's 72. 936 divided by 3. Yeah, that works. 936 divided by 72. Yep. And 216 divided by 3, 72. So this looks like it's actually, if I reduce it all the way down, 3/13. And so I could write it 3 out of 13, 3 to 13, or 3 to 13. So that's the company's contribution. So 3 for every 13, right? It wanted the ratio, so there it is. We still have not answered the most important question from this problem. How much does he have in his retirement? This question needs more information, specifically the rate at which the bank will give him interest into the account. With the rate, the number of years invested, and the total amount invested, we can use Excel to find the total in the account. To find the total in the retirement account, we have to use the future value function. So equals FV, monthly rate, number of payments, negative monthly contribution. So this is very, very, very similar to the PV function. FV, PV, very similar as to what you enter in. Excel is the only program able to use this formula. That's, of course, not true. Any spreadsheet program will work. It doesn't have to be Excel. Your calculator cannot find the value of the loan unless you have a graphing calculator or a calculator with finance functions in it. Um, but every calculator is different, so I can't go over all of the calculators right now. But a spreadsheet program most certainly can do it. Excel is not the only one. Numbers, if you're on a Mac or on an iPad, and then Google Sheets works. Open Office, they all have the same function. These are very basic functions. Find the total number in retirement account after 30 years with an APR of 6.55. So I think the first thing I need to figure out is how much is going into the account. So what's going into the account? 200 bucks from John and 60 bucks from his work. So that's 260 a month. So need to make that note. Okay. 30 years, we got the APR. Yeah, should be good. So this is the future value function, and 6.55% divided by 12, 12 by 30, and then minus 260 per month. This will give us what is in the retirement account. Okay. All right. So that's exactly what I'm going to type into Excel. And the rate is 6.55% divided by 12, 12 by 30, and then minus 260. There we go. That's what's in the account. Okay. So if there's any questions of how I calculate that, please let me know. That did not work the way I wanted it to. Okay. 294.16. 73. And I used Excel to find that value. Mm. How much interest was earned in the account over the 30 years? Well, 260 a month, every month for 30 years is the total paid. Okay. So what's that? There's total paid. That's the total in the account. So the difference must be the interest. So the interest is the total. And I would say the borrowed, but now it's total. It's not even total paid. Total saved? Because I'm still thinking about loans. Maybe I should say saved, contributed. I don't, let's just say saved. All right. Minus 93,600. There we go. Okay. 290, 416, 73. All right, there it is. 196, 196, 816, 73. 196, 816, 73. So that's just interest. Okay. Are there any questions, comments, concerns about how I found that? Just the interest. How much more was in the account than what Johnny deposited? Is this different than the previous question? Yes, because it's a different question. So that's kind of a silly sub question. How much and more is in, well, what Johnny put in? Johnny put in 200 times 12 times 30. Okay. So 200 times 12 times 30 is that 72 we found before. Okay. How much was in the account? That's the total in the account. So I need to take the difference. Four one six 73. And there is, that's not right. I hit the wrong button somewhere. Minus 72. There we go. 218,416,73. 416,73. So that's, I guess, Johnny's profit on this. He made more than $200,000 on his $72,000. So that's quite a lot. Okay. So that's how much more was in the account than what Johnny deposited. So this is how much more. Right? Any questions about any of that? Consider the following: $400 contribution, APR, 45 years. Find the amount in the account after 45 years. All right, well, how do I find that? I'm going to have to use Excel. So future value, here's the rate, divided by 12. 12 by 45. Okay. And they're putting $400, which is quite a lot, I think, for an account like this. It's quite a lot to put in each month, but good for them. So equals future value, 3.85% divided by 12, 12 by 45 minus $400. And there it is. 578,382. 87. 578,382. Okay. how much has the person deposited into the account total? So this is how much they put in. And they put in 400 a month, 12, 45. Okay. Let's use a regular calculator for that. 400 times 12 times 45, $216,000. How much interest has the account accumulated? So that would be the difference between how much is in the account and how much they contributed. So interest would be the total balance or the total amount minus that which was saved. Okay. So 578,382,87 minus 216. There we go. That should do it. Hmm. 362,382,87. So that is the interest. Okay. So how much interest has the account accumulated? So they put in 216,000 after over 45 years. This is what the balance of the account accrued, and the difference must be the interest. So that's what they're making out of it. How much interest is in the account with the APR of 399, 42 years, deposits $375 each month? They only want the interest, so they don't care about any of the in-between steps. But they have to go through all that to find the interest. So equals future value 399 divided by 12, 12 by 42 years. And how much are they putting in the account? 375. Okay, this will be what's in the account after the 42 years. Okay, so let's find that. $375. All right. 488 14687. 488 167 87. So this we found from Excel. And with this is the what's in the account after the 42 years. But that's not what they put in. What they put in was $375 each month, each year. So I also need to write that down and figure out what that is. 42. Okay. So let's figure out what that is. 375 times 12 times 42 years, $189,000. Okay. The difference must be the interest, right? Melinda put this amount of money over the 42 years. This is the amount in the account. So the difference must be the interest. So the interest is the balance, the total, minus that which was saved. Okay. So in this case, we need to subtract these two. There we go. Minus what Melinda contributed. And there it is. So that's just interest. That's just basically profit. 299,146.87. 299,146.87. That's the interest. Okay. All right. Any questions over this? Is it making sense how I'm getting it? Are there any questions, comments, or concerns about this? All right, number 4. Calculate the profit of Kurt's retirement account. He contributes $600 each month with the APR of 5.25%. He does this for 38 years, and his company does a 40% match each month. So this wants profit. Okay, what is profit? So that's anything more than what Kurt contributed. That's the deal. So Kurt's putting $600 each month for 38 years. Anything more than that he gets out of the account is profit. Okay. So I need to do a couple steps to figure out how much that would be, but I can do that fairly quickly. So 600 each month, 38 years. This is what Kurt contributed to his account. $273,600. So anything more than that is profit. Anything more than this would have to be the profit. Okay. So what's going into the account each month? The company is contributing 40% of whatever he contributes. So maybe I should also make a note of that. So $600 times 40%. It's $240. Okay. And he's already contributing 600. So that's going to be 840 each month. Each month, 840. Okay. Another way we could have done that is we could have taken the 600 and times it by 1.4. And that was our percentage increase problems. It's another way you can do it. So 840 there. But that's being contributed each month. So 840 per month into the account. All right. We have the APR. We have the amount of time. We can now enter this in Excel. So equals future value 5.25% divided by 12, 12 by 38 years. And then how much is going in? 840. Okay. So that would do it. All right. Now I got to actually enter that in. So equals future value 5.25% divided by 12. 12 by 38 years. 840. And there it is. So over $1 million. Quite a bit. Okay. I wonder if I'm going too fast, if it makes sense. Okay. So far, so good. Does it make sense? All right. So that's what comes out of the account. And we used Excel to find that. So anything more than this number is profit. Anything more is just profit. Okay. So what is the profit? That's what we got out of the account minus what we put in. Okay. So let's find that number. Minus 273, 600. There it is. That's the profit. That's how much money Kurt made off of this whole thing. It's quite a bit. So good for them. All right. There's my profit. Okay. So that's profit. But there's a lot of steps in between. All right. So how much money should be in a retirement account? Somebody contributes $250 for 20 years and the bank gives them a rate of 2%. So this one, much more straightforward than what we did previously. We have $250 each month for 20 years, 2%. Okay, so let's do it. How would you calculate this? We're going to do future value, 2% every month, 12, 20 years, $250. Okay, so again, I have to use Excel to do this. I'm not going to calculate that by hand. So future value, 2% divided by 12, 12 by 20 minus $250. Okay, and there we have it. So still quite a bit of money there. Smaller than Kurt's amount, but not bad. Why did it do that? Oh, it's acting up, huh? There we go. Okay, so there we have it. Now this one, I really, 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 really want you to come back. If you drifted off and you got sleepy while I went over those problems, please come back because this one always in some way shows up on the exam. Okay, so watch out for this. It might not be the same numbers, but it'll be this idea. Number 6, can you make up for lost time by increasing your contribution? Find the total in each account. Okay, so here's the idea. Would you get the same amount in the end for half the cost, twice the time, or twice the contribution for half the time? It seems like you would, right? So if we did $300 for 40 years, same APR, instead of $60, 20 years, which one's going to have more, right? Can you make up for lost time by doubling it with half the time? The quick answer is no, you can't. And it's because of the percentage. Because you make interest on interest, you can't make it up. All right. So I'm going to prove it to you by using Excel, but that's the idea. So I'll do the two different accounts. I mean, if this thing worked like a straight line, it would work, but it's not a straight line. It's interest, and you make interest on interest. So that's why you can't do it. So the interest rate for both of them is 3% divided by 12, 12 by 40, and we're going to put in $300. Okay, so that's the first account. Then the second account is $600, same interest, but half the time. Okay, and you think, well, of course it should end up being the same, but it isn't because you're not going to make that interest on the interest. So saving early, even if it's less, is more important than saving more later. Sad but true. So this one's 20 years minus 600. So they will have contributed the same amount of money in both accounts, but the amount won't be the same. So you can see it's less, even though they contributed the same amount of money. Okay. So that is non-intuitive that would be the case. But that's the deal with it making interest on interest. So the more time is more important than the amount of money. Okay. I'll save that for your notes so you can see the difference in the price. There you go. Okay. But even though they contributed the same amount of money, they're not going to get the same amount back. Okay, let's go normal calculator. So 300 times 12 times 40, that's what they contributed into the account, $144,000, right? Okay, 600 times, whoops, 600 times 12 times 20, $144,000. They contributed the same amount of money. The difference is the time. Okay, so even though they put the same amount of money in the account and the same interest rate, different time, different outcome. Okay, so it's not the same. And there's always a question on the exam that asks that in some way. Would doubling the contribution but having the time give you the same outcome? And it does not. It does not. Okay. So that's the deal. And it's non-intuitive that would be the case. Okay. So I hope that makes sense. I hope it's clear at least that they are not the same. And I'll save this for your notes later. Okay. Any questions about this? Any questions, comments, or concerns about this? Okay. So what we're going to do is we're going to take a look at project 2. So sometimes all the semesters change because Ivy Tech changes the schedule almost every semester at this point. But sometimes the section 12 lands on, so the only thing would be due for a week would be section 12 and the project. And so you'd be ending the financial and then you'd start project 2. But with our schedule, the way the months and weeks landed, you're going to have all the financial project, and then you're going to take your exam, and then you're going to submit the project. So it's just the way the calendar landed for our first 8 weeks of the spring semester. So it's just the way the calendar hit. Okay. So I want to introduce the project now because it has to do with all that finance. So today I'm just going to introduce it, and then next week I'll re-explain it, and then it'll be due. Okay, so that's the idea. So next week we're going to review for the exam and then review what we do with the project, however we end with the project today, we'll review that, and that'll be what we're doing not tomorrow, but next week. Okay, so let me go to the class website and we will start discussing the project. I know every teacher is going to say this, right? But if you can get started on the project, you should, because it's going to sneak up on you really quickly and you don't want to have it hanging over you, okay? So project 2 is quite a bit harder than project 1, and it's going to be our finance project, all right? So here's the deal. Of course, you have all the instructions right here that you can read for yourself, and I expect you to. But here's the deal. You're going to make the project basically for two people. The first person is someone that makes $22,500. Okay, so that's the first person. So what you're going to find is you're going to find um, the amount that they could um, borrow for a house. So let's take a look at that. You have an APR listed, 30 years, and 28% of their income goes towards the house, goes towards the mortgage. So we can find their home loan for this person. Okay. So we can do that just like we did with with the homework. So what's the highest price the house can afford? Um, and then we're going to do absolute change for the two people. And later you're going to research housing costs in the city you would like to live in. So you are going to pick a city with this project. Please keep it within the United States for this project. I understand you might be interested in somewhere outside of the States, but for this project, I would like you to pick some city, any city you want, uh, and research housing costs for that city. Okay. So you pick the city, right? But you have to tell me in the project which city you picked. Using Excel, we're going to go backwards and we're going to find out how much of our um, monthly mortgage went into that. Okay. And then we're going to do a retirement. So assume that you selected a job for retirement, 32 years, 4% of our monthly income goes into the retirement, and we have that 899 APR. And then we're going to do that for both people. So first thing to start with is you have to pick a job. So you're going to school, obviously. So I assume you're going to go to school to get a job somewhere. And the first thing you need to do is find that median income for the job. And you're going to use this website right here to find that median income. So let's do that. So I'll open this up and then I'm going to find some job. I can look it up. I can just type it in, or I can go through the different categories. So that's the two different ways you could go. You could type this in and just search it, or you could go, I want to do something in one of these categories and then look it up. All right, so I'm going to do one for me. You'd think I'd do math, but I'm not actually going to do math. I'm going to do education because I want to become a teacher. So I don't want to be a high school teacher. I want to teach at Ivy Tech. So I'm going to go post-secondary. That looks good. And it looks like the 2022 median pay for post-secondary was 80,840 per year. Okay. So that would be good enough for my project. So I'd say, okay, I need something around 81,000. You can go even more specific if you're interested. So we could even go into the state if you want or similar. I mean, you might actually find yourself getting interested in, what things are going. So I could go into, see what I just clicked there. I'm going to go state and area. Maybe I can even get more specific. You can see I've been here before. So math teacher, post-secondary, that might be of interest to me. I'm looking for Indiana here, and we see, looks like we've got to go different types of green, and we have some states listed there. It's interesting. Location quotient, um, Montana. So I'm looking, maybe you're going to move to one of these cities so you could find your profession, your, uh, that type of thing. Here's Bloomington, Illinois. It's not Bloomington, Indiana, but it's Bloomington, uh, Illinois. Again, that would probably be good enough for my project of interest. I can tell you that it's pretty close. Not for the job I have now, but that would be for a full-time professor. So you might actually find yourself interested in some of these numbers with whatever profession you're going to do. So for today, I'm going to say this is good enough for me. Yeah, it's Illinois, it's not Indiana, but and I also know the going rate, and that's pretty close to the full-time math at Ivy Tech here in Indiana. So I'm going to go with that one. I could have went with the first one, but I'm going to go with a more realistic number because I'm starting to get interested. Okay. So, what is going on with my project here? So, I'm going to just jot this number down so I don't forget it. But here's the deal with the project, you have two people that you're going to do the project for. One of them is someone that makes 22,500, and the other one is someone that makes the median income of the job that you're going for. Okay, so you have two people, and in the project, it calls one of them the high school grad, and I guess the other person in my project would be, I'm going to call it math professor. Okay, so the math professor makes this, and the high school grad is 22,500. Okay. So again, I'm making the project for two different people, right? So I can do that, but that's the deal. I'm assuming you don't want to be a math professor. Maybe you want to be, I don't, I often get a lot of nurse projects, but um whatever, you pick what you want. Pick one of those jobs, something you're interested in. Maybe you're going for computers, maybe you're going for nursing, maybe you're going for radiation tech, maybe I don't know. There's a number of things you could be going for. I don't know. Pre-law, I don't know. Whatever it is, try to find something on there and list it for me. That would be super duper if you could list it for me. You can also get kind of fancy, and you could even um, do links. I think there's a number of ways to actually link things. So you can do a hyperlink and tell me the address. So if we wanted to get super fancy, I could even link the, um, you don't have to do that, but you can even link the number, especially if you're doing a report for something for your job or whatever. You can set that link. And so if someone's interested, they could click it and then you know, see where you got that number from if they're interested. You don't have to do that for my project here, but it's good to know that that's available. So there's a high school grad. Now, what's going on with the two people? We're going to buy them a house, right? So let's go back and see what's going on. So with the house, APR is 1.7 for both people. It's 30 years for both people. And they're going to spend 28% of their income for both people. They just have different incomes. All right. So I think first thing we should do is maybe figure out um, how much they're going to put in. So 28% of their income. Okay, so how could I do that? I could take this times, um, let's do 28% times this divided by 12. So that's they $525 a month that they could put in. Okay, maybe I'll put monthly. There we go. Okay, I should do the same for this person. So I'll just copy and paste. I'll be lazy, copy and paste there. Same idea. So I want 28%, this divided by 12, and they can spend this a month for 28 a month. All right. Now they both have the same APR. That's the same for both people. I think it was 1.7. Let me double check. 1.7. 1.7%. Okay. There's the APR. So far, so good. All right. Let's check that project again. 30 years for both people. Everybody's getting a 30-year loan. All right. So time is 30 years. All right. So I think already we could find that house because we know how much monthly, we know the APR, we'd be good to go. So I think we can also find the loan today. So that's going to be present value because we know how much they can spend a month. And we know the rate is 1.7% divided by 12. 12 by 30 minus $525. And I need to stretch this out a little bit. There we go. Okay, so this is my first guess of that home loan that they could do if they put 28% of their income towards it. Okay, I would do that with the math professor as well. So they're also going to have a loan. Whoa. And so equals present value, and that's 1.7% divided by 12. 12 by 30 years minus this amount. There we go. That's the maximum house they could get. In reality, it would be lower because, of course, they probably already have some loans out there. So we have to decrease that. And in reality, you have to have homeowners insurance. So you got to go less than that. But for the project, that's what we're looking at. Okay. So that's just getting going. That's the idea of just getting going. And that's really, I mean, if you did just that part this week, that's really what I need you to do. Just kind of get started, find your profession on this website. Really, just getting started would be great if you can also do the assignments as well, of course. But if you just got that far, that would mean a lot. Okay. So, what's the highest price you can afford on the information above? What's the highest price the high school graduate can afford? So, that's what we found earlier. Use the absolute and relative change statements to compare the house prices of the high school graduate and your house. So, absolute and relative change, we've talked about new minus old, and then that percentage increase many times before. So, we want to find that. So, that's all part of question 2. So I could find absolute change. Okay. So what do? I could take new minus old, and that would be the difference in amount of the two homes. The relative change is what? It's the absolute change divided by the reference value. Okay. So we see it's 200% more. This is 200% more. If you, I mean, that's good. You can, all I'm asking you to do is to write that number down. You don't have to do that, but you can also turn that into a percent if you want just by, let's do that again. I can do that by just clicking the percent button. Turns into 201% more. 201% more. All right. Research housing costs for the city you would like to live in. Use cities within the United States. Assume the APR and the years of the mortgage are still the same in question number 2, 1.7% in 30 years. Using Excel, find the amount needed for the monthly mortgage. Use a relative absolute change sentence. Compare the monthly price to the house in question 2. Calculate the percentage of the monthly gross income this payment would be of your salary. All right, sounds like I need to research some housing costs. So, well, What city do I want to live in? And where am I going to research these? You can use any website you want. I'm not too strict about this, but I might as well use Zillow. I mean, it's the website I used for to find the house I'm sitting in. So it does work. It's just not in truth, Zillow can be quite a bit off. I don't know if you've used Zillow before, but it can be a bit off. Let's look up Zillow Bloomington. Oh, there's a nice $1 million house I could get. Um, let's see. Well, I guess I'm gonna be a full-time math professor, so um I could kind of splurge here. This looks like that might be nice. 375. This I could live here. That looks good enough for me, huh? Yeah, some of these are quite nice. All right, I just got to pick one, but it looks like I'm in the right place. It does look like if I got my dream job with my dream income, it looks like I could do it. And frankly, any of these houses look good enough for me. That looks a little bit too good for me. This one, I like the trees here. This might be nice. Could be a lot of mowing I have to do though. Um, yeah. So I'd say any of these. It looks like I'm at least in the right place, you know. So these look good, but I don't have to go my maximum. This looks big. Um, so you know what? I'm just gonna pick one, go with it. This looks good enough for me. It looks nice. So let's see what Zillow says. If it loads. I have a lot of program. Oh, this looks good enough for me to live in here. This looks good enough for me. It's 375,000, 3 beds, 2 baths, almost 2,000 square feet. Yeah, I could live here. So it's good enough. All right, that's the one I picked for my project. That's uh how much time I went into it. So, um, how should I label this? Bloomington home is $375,000. Okay. Again, if you want, you could, especially if you were doing this in a more serious way, you can reference this. Also, if you ever go into those home loan meetings with one of the bankers, it always is a really good move to have all your stuff labeled so you can move quickly. So I'm going to do it, but I'm not requiring it for the project. So I can go back if I want. So I have $365,000 and I could have went up to 444. So I'm gonna save a little money, make things a little bit easier. So there we go. That's the house I picked. Now let's go back to the project. And so it says research the housing costs, and we're going to use the same APR, and we're going to use the same 30 years, and I guess we would want to find the payments now. So I can find the payments on this house if I had the same APR. So the payments on this house equals PMT 1.7% divided by 12, 12 by 30 years, and then minus my house. So there's the monthly payments, which we can see is less, of course, than the 28%, but how much less is of interest to us. So using Excel, find the amount needed for the monthly mortgage. Did it. Use relative and absolute change sentences comparing the monthly price to the house in question 2. Then calculate the percentage monthly. All right. So absolute change equals, if we want, we could go this minus this. And we see that that's a negative number. And we're saving by choosing a less expensive house this much each month. Okay. Relative equals don't know if it's going to be mad about this. So this is a percentage. So roughly 6%, 16% less. All right. But you might want to pick a house that's more expensive. I don't know. It's up to you. I just randomly picked this house. So that's it. Now, the other part was the percentage of the income. Okay. Percent of gross, right? Okay. So how do I do that? This over monthly gross. Okay. So I need to find my monthly income. All right. So equals this divided by, I'm going to use parentheses this morning. We want to go this divided by 12. And then turn that to a percentage. And I'm finding it was roughly 24% of my monthly income, which sounds about right. We knew it was less than 28%. Okay, so there you go. All right, that makes at least common sense. Okay, so that's question 3. All right, and again, today the only thing I wanted to do was introduce it. So we're just introducing it, just getting you started. Retirement account, assume that you selected a job with a retirement plan that can save for 32 years, 4% of the income. APR is 899. How much would the high school graduate expect to get? Using absolute relative change, we're going to compare them. Okay. So let's see if we can look at that. So for the retirement, what can we do? They said the APR, I'll put this here, was 899, I think is what I just read. Yep. And the time was 32 years. Okay. And we're going to do 4% of our account. Okay. So 4% of income. This person makes 22,500. Okay. So equals equals 4% times divided by 12. $75 a month. That sounds about right to me. Check that. Yeah. So they're putting $75 down. That's good. So now we want to find the 401, often called 401k. I'm just going to call it 401k. This is a retirement program. So future value. All right. And it's 899% divided by 12. 12 by the 32 years minus the $75 we just calculated. And that's what they'll have after retirement or in their account. So great. Okay. Now let's do that for the math professor. Okay. They are also going to have a retirement. And what can we say about theirs? Well, we need to find the 4% of their monthly income. So let's do that. Equals 4% times divided by 12. All right. $225.43 every month. Okay. So the 401k is going to be what? So equals future value. And that's 8.99% divided by 12. 12 by 32 years minus $225.43. And that's what they'll have in their retirement account after the 32 years. Okay. So that's a good start. Now we were supposed to use absolute and relative change to compare the two accounts. So equals and relative equals absolute divided by, and that's a percentage. And we see that that is also uh, 201. So that's interesting. Same. Interesting. Okay. That's well more than I need you to do this week, but that at least will get you started. Um, Use absolute and relative statements. Compare the retirement accounts of the high school. Make sure you show at least one sample formula and retirement price. The last thing is a salary increase. Considering working for a company that gives you two options. You can take a wage increase of 1.5%, or you can take a lump sum of 825. Write a scenario you would do for job A, for your job, A or B. Explain why you chose this, and what should the high school student choose? Choose A or B. So, is the percentage the better increase, or is the lump sum the better increase? Okay, so I'm going to do a raise. All right, so the raise is either 1.5% equals 1.5% times this person's salary, $337.57, or do we want lump sum? Looks like for this person, I want the lump sum, okay, because it's more. For this person, let's see, 1.5% equals 1.5% times their salary. And this one's over $1,000. So they certainly want to take the percentage. Right? So the more you make, the more the percentage would be over the lump sum. So for this person, I would suggest taking the percentage. For this person, I would suggest the lump sum. Okay. So should you take a high school A or B? High school graduate. So that's what I would choose. Okay. That's almost all the project. Now, of course, you have to answer the questions and write it all out, but that's pretty much the project itself. Okay. So I'm going to hopefully hit take quiz, show you how you'd enter this stuff in. The first thing is you upload your spreadsheet. Then you explain what job you've chosen. Then you explain everything we calculated, but you're going to explain it in your own words, full, complete sentences. Okay. And that's how you actually enter it in. You don't have to enter in a Word document. You just enter in the text file there. Okay. So today is just introducing the project. Okay. But keep in mind you have 3 homeworks in the quiz due this week. Okay. So you have 10, 11 due on Friday, and you've got 12 and a quiz due before class on Tuesday. Okay. Project, if you can get started, at least get Excel going. I think that would be good, while you're thinking about that. I think that would be a good move to make. And then next week, we'll talk about the exam, we'll talk more about the project, and that'll be enough for that. So I'm going to hang out for questions, but that's it for this week. It's a lot, so give yourself a lot of homework time, and get a hold of me if you get stuck, okay? But that's it for the prepared lecture. So I'll stop the recording and I'll stick around for questions.